Hello, can you hear me? Great. So welcome everyone. So we got kind of small screens in this room, so we're going to have a little bit of code demo in the middle of this. If you're interested in reading the code, you might want to come a little forward, but if you have great eyes, it'll probably be okay. My name is Chris Brooks. I'm part of the Azure storage team in Redmond. And I'm here today to talk about Azure Cloud Storage, specifically our object store service, and how it works for both developers as well as solutions that are built on it for IT. And I'm really looking forward to sharing it with you. I'd also love to connect with anyone after. If you've got storage scenarios that you'd like to ask questions about or share with me, I drive things like security, features around change tracking, management. So if you got areas around that, you have feedback on the product on, catch me tonight, catch me after the session, and I'd love to talk with you. So here's what we're going to cover today. We're going to do a little bit of an Azure storage introduction. Then we're going to dive deeper into our object storage, the blob storage service, and talk about a few capabilities it has. We'll talk about a little deeper on how to use it, and then we'll, along the way, touch on a couple of customer stories to talk about how they were using Azure storage in various ways. So let's dive in. So maybe I'll start with getting a sense of who's in the room. How many people in here call yourself a developer or an application architect? Oh, a couple. Okay, most people in here do infrastructure work, storage, servers. Okay. Either way, you guys probably face this challenge about storage, which is that inherently, storage today always has scalability to them. It's because you always decide to purchase some amount, and it's got some ceiling, and you're trying to build a solution, and so you always have to guess. Is that going to be enough? I think that'll be enough for the next however long I can predict in the future, and you pick something that size, and then inevitably it's either too big, and you spent way more money than you need to, or it's too small. And as you grow, changing to a larger one or distributing it is always a really complicated problem. So that inherent scalability limit and the balance of it can be a real challenge for customers. Also, when you're in charge of storage, it's inherently a risk management business. Your job is to never lose the data, right? There's a reason we're investing all this money. You can't lose the data. You have to make sure that it's reliable and it's durable, but also that it doesn't fall into the wrong hands. So you're in charge of some important security around the data. And often, depending on the business you're in, you may have regulatory or legal obligations in terms of how you protect that data. So a lot of what you do is risk management. And in general, it's pretty expensive. So not only do you have to often buy these expensive storage arrays, but you have to have a data center to put them in with power and network and space and cooling. And so it's just expensive to do, both in stuff and also in people hours to manage those solutions. And then inevitably, as we said before, because of the scalability problem, you'll have to buy something that's larger than you need right now. And so the whole time you grow into that, you've essentially paid more than you need to. So you're paying twice as much as you should, maybe per gigabyte. And so these things put together kind of lead businesses to a place where they feel constrained. It's too expensive to take risks, to experiment, and they often get in a place where they hesitate to move forward. So Azure tries to address these challenges in a few ways. First, we offer essentially limitless scalability. So we have a service that's globally distributed, that's works at internet scale. So the numbers are really staggering. So today we have about 120 trillion objects stored in Azure storage. Trillion's a big number to get your head wrapped around, but that's a lot of objects. Another way to think about it is we do about 19 million transactions per second. I'll let that sink in with you a minute. That's per second. So add that up to per hour, per day, per month, and it starts to be really, really big numbers. And that's the business we're in. So it's our nature to build something that's that scalable. And so any individual customer, as they need to use a large amount of storage, it's not even a blip for us, right? That's just what we're designed to do, is to scale up. Let's see. Just in terms of scale and locations, where we can be is also part of that scale, so being close to your customers. We have about 30 Azure locations today, 8 more in the process of coming online. And Storage is in every one of these regions because storage is a fundamental service in Azure. All the other Azure services are built on top of storage to store their data. And so anywhere there's an Azure region, storage is among the first services deployed there to create a region. Okay, so trust. So we talked about the risk of managing your data, making sure you don't lose it, making sure you can secure it. This is essentially where we've done huge amounts of engineering investment. So start with durability. We do a large amount of work to make sure that your data is never lost. That includes making multiple copies of the data, replication across regions, as well as background scrubbing to make sure your data doesn't degrade over time. We also spend a huge amount of effort just on security, but whether that's physical security in our data centers and the processes we use, but also the features that we build, make sure that they're secure and that you can build secure solutions on top of them. And finally, we invest a huge amount of money making sure that that you can trust our solutions in these spaces, and we do that through compliance with various standards. And so this is just an example of this, of some of them. Azure is far and away the leader in terms of compliance of our cloud solutions, and whether those are industry-specific solutions or government certifications, we have a huge lead in this space. And so that really helps various customers build solutions that they know they can meet their obligations with. And that also is just part of being Microsoft in our history. We're oriented towards enterprises and the kind of work they have to do, and customers trust us with their data, and so that's important to us, and it's important for us to maintain that. So let's talk about economics. First of all, we do this at a kind of a scale. We just talked about that no customer can do or would do, and what that leads to is the ability to have economies of scale in terms of our purchasing, in terms of our the way we operate data centers, the amount of automation we do, that allows us to do things at a level of cost that customers just couldn't do. And so that really helps us drive the cost of storage way down. We also have a pay-as-you-go pricing model. So for a customer, instead of having to make huge investments that may or may not pay off, that are big and risky, you just essentially use the storage and pay for what you use. So that's a really attractive model. And that means you can start with a little, you can grow very fast and use a lot, you can change your mind and shrink back down and not use it, and you just pay for what you used over that time. So it's really exactly tied to paying for what you consume, which is what people try to do with their planning models, but never works. The other thing is this is a very competitive industry. And so we're constantly innovating and trying to drive our capabilities as well as our operational cost down. And we're always in a race with our competitor to offer a least cost solution here, because this is essentially a commodity business in many ways to customers. And so as we do those innovations, as we can drive the cost down and as our prices come down, you get immediate benefit for that across all the solutions you've already deployed. Whereas with typical on-premise solutions, maybe you could buy a new SAN that has some new technology that's a little more efficient and a little cheaper, but you only get the benefit when you buy a new one and your work going forward. But all your existing solutions are working on old infrastructure that you're depreciating on the old cost. So in our case, we lower our prices. All your existing storage goes down to those prices right away, and so you get the benefit of this innovation over time. And all these things add up to really putting businesses in a much more agile place, and let them take risks, let them innovate, and do things they couldn't do before, frankly. So what is Azure Storage? We like to talk about our services sort of in two buckets, both infrastructure services and platform services, which are more higher-level services developers would typically consume. So on the infrastructure side, we have two. We have disks, and so these are essentially the persistent disks that you attach to VMs in Azure. They're used, they're attached just to one VM at a time. They're single use, and these include magnetic media and also high-performance SSD-based media to meet sort of high IOPS, low latency kind of scenarios. And then we have a file service, which is essentially a shared file service, essentially SMB service in the cloud that you can use to have your VM solutions connect to directly over SMB. And it essentially fits that scenario where you have applications that are used to that scenario. You want to lift them into the cloud, but you need a file share solution that works there. So that's what the file service is for. And then we have three PaaS services, objects, tables, and queues. Objects are the one we're going to talk more about today. It's essentially for non-structured data. We call them blobs. Essentially, you can think of it as files or other things, other non-structured data, sequences of bytes, right? It's really arbitrary and up to you what you put in them. But doing that at a super high scale, so super large amounts of data, super high transaction rates. We include both sequential and random I/O sort of access pattern features. We'll talk about more in the future. Different tiers of access for cost and for archive purposes, things like that. So we'll talk more about that in a minute. And then tables is our key values NoSQL solution. So if you need to store structured data, that's the tables service. So this is something, for instance, Xbox uses to store user profiles or to store game progress, things like that. So a simple structured store, again, super highly scalable, very simple, very cost-effective solution. And then queues is a simple messaging solution between components, also scales, very simple, very reliable, and also very, very cost-effective. So that's the Azure Storage Services overall. Now we're going to drive deeper into objects, but all these are built on a shared distributed storage system that provides things like durability, encryption, replication across regions, fault tolerance, load balancing, things like that. So they all share that engineering investment, and as we make progress there, as we innovate there, all these services get the benefit of that. Okay, so let's talk about object storage. So what is the object storage service? As we said, this is a service designed to store and serve unstructured data. So that could be data from your apps. Maybe it's pictures or media apps or other web scale data. This can be big data sources. So if you've got devices feeding out telemetry or other IoT scenarios and a huge amount of data, it's a great place to store that quantity of data. Large data from science scenarios like genomics, et cetera. And also, we sort of a little more pedestrian scenario of where do I store my backups and archives that I need to do in a very reliable, very cheap way. We're a great place for that kind of thing. So what are the key features of Blob Store? One is just the amount of data you can store. So you can store petabytes of data in blob storage. It's very durable. You can choose the level of durability and to fit your scenario. We're highly available. We provide a 3 nines SLA. We usually operate at much higher than that. If you include geo-replication and you're willing to read from your replica or your primary, we can offer you a 4 nines SLA to availability of your data. We're strongly consistent. This is unique to us compared to our competitors. So when you write data to Azure Storage, to object storage, it's immediately committed everywhere and consistent to anyone who reads that data from that point on. So we're not an eventually consistent model like you'll see in some competitor products. And then we dynamically scale. So this is really the secret sauce of our infrastructure, is that as your particular set of data starts to get hot and starts to get used much more often, we can allocate more resources to serve that set of data. And as it cools back off and it's used less often, we can use those resources in other places. So we do this invisibly. You don't have to plan any of this. It just happens automatically behind the scenes. And again, we're very cost effective. So we are in a constant race to provide leadership in terms of cost in this space. Okay, so let's drill into a little more about durability. The base option is what we call LRS, locally redundant storage. So this is essentially storing 3 replicas of your data within the region that holds your storage account. And these replicas are always on a server that's in a different rack. So you can think of, I write a piece of data, I make sure that data gets written to 3 different racks in 3 different parts of the region, so that we're resilient to disk failure or a node failure or even a rack failure. If the power goes out for the whole rack or the top of the network switch goes out, that's no problem. We still have 2 other copies to read from, and we can immediately replicate it to another place. So we only acknowledge a write once all 3 of those writes are committed and successful. So this is how we get our strong consistency model. And this model is actually better than a typical dual parity RAID kind of a scenario in terms of its durability. We also, on top of this, offer what we call GRS. So this is globally redundant storage. So the idea here is that after we write those 3 replicas to one region, we will immediately start to replicate it asynchronously to a secondary region. And so it's available there in case we have to fail over in case of a disaster. So this protects against the idea of a flood or an airplane crashing into the data center, some really disaster that we can't recover from. And this, as I said, these get replicated asynchronously. And then we allow you to take that secondary and make it readable itself if you'd like to. So you can have applications read from that secondary, and you can also let them inspect how current that secondary is. So how many minutes behind is that replication, so you can always be sure you know what you're reading from. So that's the durability option. So again, behind the scenes on all this, we're constantly doing scrubbing on your data, making sure we're doing checksum and CRC checks on your data. And if you've heard of this idea of bit rot, if you have little bits of a file that may degrade over time, we're always detecting that, and we can repair those things constantly in the background. All right. So blob storage. So what scenarios are great for blob storage? Again, limitless scale. It's globally accessible, so you can put this wherever your users are. It's very cost efficient. So this means it can be used for things like the live data for your application when you're storing data, but can also be used for archiving, and also used for things like big data analytics. So if you have a huge amount of data that needs to flow into somewhere and then operate on it later, it's a great source for that. So I'd like to talk briefly about one customer who's used object storage to transform one of their key business systems. So this is CarMax. CarMax is a used car retailer in the States that one of the largest. So they have stores all over the country, 160 or so stores. They also have, you expect, a big online presence, which is a key part of how they market and sell their cars. So maybe we'll just take a look at them just to show. Okay, so this is CarMax.com. So it's what you'd expect, e-commerce site. You search for kinds of cars you want in the location you are. You find ones you like. And obviously, the shopping experience for cars is often largely about looking at the car. How does it look? How do I feel about it? And these pictures are a key part of that shopping experience. So the ability to look at pictures and navigate through them really makes a difference. And so these images for CarMax are actually served by a distinct service called their image service, which we'll talk about in a minute. So this is a link directly to the URL for this vehicle image. And you'll notice that at the end, it's a number.jpg. This is actually a dynamically sized generated image. So they use this to provide an adaptive experience in their shopping to different sizes of screens, to mobile, et cetera. And so, for instance, if I wanted a smaller image in some scenarios, I can do that. I get a smaller image. So this is their front-end service that dynamically provides the right size of a particular image. So, so let's talk about how they built this. So originally, this was built using an all on-premise solution. And the way it worked was sales people in the stores, as a new car would come in, would take a bunch of pictures of the car, and then they would use a desktop application to upload those pictures to an image service that CarMax built. And that image service would then resize that image into a few specific sizes and upload it to a SAN that they had built and bought just for this purpose. And then they built a relatively simple static website on top of that SAN to expose those images that their e-commerce sites and other properties would use. And this worked pretty well until they really started to grow. And the size of the SAN they had bought, they started to run out of space. And they also decided that they needed to do more. They decided, we need higher resolution images. We'd like to do more with this. And they were really constrained by this fact in their solution. And so they went to trying to compress images, and they went to try to buy new SANs. And all these things were really painful, especially trying to acquire a new SAN and copy the data over. Takes a huge amount of time. They just couldn't find really a successful way to operate in this. And so they decided to look at, what could we do with the cloud? What could we do with Azure to address this? And so they built a solution using Azure Object Storage. It works exactly the same way for the people in the stores. They still take their pictures and they use that desktop application. But now that original image is uploaded directly to Azure Blob Storage. And then it's served by an Azure web application that does that dynamic resizing. So both of those pieces are now running in Azure. And now that they can scale this to as much as they need, they have sort of infinite scale on the images that they store. And it's really a great solution. They also use this idea of a read-accessible replica to provide a secondary copy of their data, and actually an always-on copy that they use even for live traffic. So you can imagine it's not important that when somebody checks in a car that it's available that second, and so the idea that in a couple of minutes it'll be available on all the sites is good enough for their process. And so they actually built an active set of their web application on top of the secondary as well in that region. And then they built a traffic manager front end to that, so the customers would be directed to the one that was closest to them. They get the best responsiveness. And then if there's ever a problem with either one of these locations, the traffic manager can send them to the one that's working at that moment. So a pretty good solution. They've got great benefits in this. The dynamic resizing was very valuable to them, and huge cost savings. It put them in a position to put this thing even closer to their customers as they expanded into other regions, et cetera. And so it was so valuable to them that they actually decided to move the whole e-commerce site to Azure as well. And so they did a bunch of work to move the shopping experience and the shopping website itself also to Azure. But as is true in most companies, some of the core logic, some of the core features that were required for that shopping experience only really worked on premise. And so they were able to use things like application request routing, as well as Azure networking facilities to reach back into their on-premise for those particular APIs and services that needed to be there, and the rest of the application could scale in Azure. So, so very powerful, able to build this and scale this very quickly and get lots of the benefits of Azure. So it's been a really great experience for them, to the degree that they're now in a position to really add a lot of great features to their service that they really needed, that they were constrained on before. So now they can add these larger 360-degree tour photos, videos. They're going to use the image metadata to be able to provide a better experience for browsing images. So show me inside, show me outside, show me the front, show me the back, things like that. And they're also going to do some really innovative things that extend the relationship with the customer. So when they sell a car to you, now they'll be able to let those pictures be yours to use over time. And so they'll be able to preserve these images using our cool storage facility, do it at a much lower cost, and provide a service to their buyers that keeps them connected to CarMax. So if they ever want to sell their car, they feel a connection, they come back. So all around a big win for CarMax, just by taking advantage of this idea of cloud storage. Okay, so let's drill a little deeper. For the 4 or 5 devs in the room, this stuff's going to be really great for you. For the guys who aren't devs, it's great anyway. You're going to love it. You should be devs. And we'll get to how these things pay off for you in just a moment. So blobs. We have types of blobs in Azure. There's really 3 types of blobs. The first one, and the most common one, we call a block blob. So block blob, you might just think of as a whole file. It's just a block, I put it in there. But we also provide the idea that you can break a file in individual pieces and then sequentially stitch them together. And so this is really about sequential access to your data. And so that's the most common type of blob. We also have what we call append blobs, which are like block blobs, but they're optimized for that scenario where I really just write to the end of the file. So this is great for logging applications or output from big data jobs, things like that. And then finally, we have what we call page blobs. Page blobs are really about random I/O. So they're the access pattern is about 512-byte pages of data that you write into this sort of large, sparse address space. And so this is very similar, you'd think of, to writing to a disk, right, into the blocks on a disk. And in fact, that's why it was built. This was built as a service that sits behind our disk service. So in virtual machines, the disks that are attached to those are actually built on top of the page blob service. But other applications use this directly. So our Event Hub service, for instance, they use page blobs because this random I/O pattern really fits the way their application needs to work and scale. So 3 types of blobs. All right, so at a high level, how do these blobs things work? How do you get to them? People are aware of having an account with Microsoft and with Azure, and the idea that you can have multiple subscriptions that are attached to that account. And then within each one of those subscriptions, we have multiple storage accounts. So a storage account is really an abstraction that we use for billing, that we use for capacity management, and things like that. But you can have multiple of them. And then within each storage account, we have what we call containers for blobs. Now, object storage isn't like a file system where you have infinite folders and files within folders. It's really a flat system. So you have sort of one level of folder you could think of, and that's the container. So you have a container, and then within the container, you just have a collection of blobs. And these blobs can be large or small, and you can put as many in a container. You can have as many containers as you like. That's just really up to you. And then we use these different concepts, the storage account, the container, the blob, and we put them together, and they make up the URL to the blob itself. So you can imagine when you want to retrieve this particular blob, those things fit into the URL, as you see here. So this is probably easier to understand if we just look at it live. So let's do that. All right. So this is the Azure portal. We'll start at the beginning here. So in Azure portal, you see storage accounts. I've got a couple of them here already, but I'll just show you the experience of creating a new one. So when you create a storage account, you essentially need to give it a name. And the name just needs to be a unique name. It's actually today a globally unique name because it's part of that URL that we saw earlier. So give a unique name. You can build these storage accounts in a couple of different models. You guys may be familiar with classic and ARM-based resources. If you're in doubt, just use Resource Manager. That's the modern one. If you know you need classic for an old system, then you can use classic. But Resource Manager is the one you typically want. So storage accounts can have two different kinds right now. There's a general purpose account, which allows you to have blobs, tables, queues, files, all of those services in it. And then we have a specialized blob storage account. And this provides some extra services like the cool and hot tier that we'll talk about more in a minute. So if you're just going to do blob work, a blob storage account is probably the one you want. You can pick the performance tier. You can pick how is this replication happen. So do I just need copies of it in one region, or do I need to geo-replicate this? Do I want that geo-replica to be available to read? So you just pick the option here, and you can change it later if you need to. Then you pick the tiered. Is this hot data? I'm going to access it very frequently, and I want a billing plan that's optimized towards that pattern, or is it cool data? It means I'm going to put it there, and I'm basically going to leave it alone, and I want the cheapest storage cost I can get. So you can pick the one that makes sense, and then you hit create. I've got one created that we'll just use. Oh, it's okay. Well, let's use this one here that I've created. So you can see some of the things we talked about. This is a geo-redundant, read access geo-redundant. You can see that it's in the primary location. I put it in West US, and then its replica is in West Central. So these pairings are determined by us, and so you don't get to control them today. You just pick where your primary is, and then that has a designated replica location. These are today designed in a way so we can plan capacity for disaster recovery. So if we need to fail over a whole region, that we've planned the capacity we need in different places. You can also see the two different URLs, the primary and the secondary. And then you can see below is this list of containers. So I have a container that I've already put a couple of things in. We can see here. And you can see that you just have blobs. In my case, they just have file names. And you can see each of these blobs has things like the MD5 hash, whether or not it's locked, what type of blob it is. And you can even use the portal to download and look at things if you want to. So pretty straightforward, kind of basic capabilities in the portal. So that's the portal. You can also use the portal to change things about your storage account, to get to things like the access keys, connection strings, a lot of rich capabilities here. All right, so we also provide a tool called Storage Explorer. So you can just download Storage Explorer. Let's see. Where is it? At storageexplorer.com. Storage Explorer is available both on Windows as well as on Mac and Linux, and it's just a client application you can use that interact with your data in your storage account. So I have that running here. And you can see that same storage account with my containers and the blobs that are in them. And it does things like help you upload and download data, generate SAS URLs if you want to provide delegated access to people like that. It also does things like allow you to upload whole folders of data. So let's see, I wanted to upload a folder full of pictures. I can upload them. And we talked about before how there are not folder hierarchies in Azure Storage, but we do have this idea that we can understand delimiters within a path. And so if you ask us to query things by those delimiters, we can do that. And so we can make what essentially is a virtual folder experience here, right? So it looks like there's a folder, even though in really they're not folders. And so it allows you to upload and download groups of files. It does some interesting things. So if you're doing a lot of work with Azure Blobs and storage, it's a helpful tool to use for that. Okay. So let's show what the experience is like to write code against Azure Storage. So when you install the Azure SDK, included with it are a few Visual Studio projects. So let's show that here. File, new project. You'll notice here in the cloud, quick starts, data services. There's a few Azure Storage ones here. So I've picked the Azure Storage Blobs project. That's the one I'm looking at here. And essentially, this just has all the basics of getting started features for using storage. And so this particular one is just going to make sure a container exists, create it. If it doesn't, it's going to upload a blob, and then it's going to delete the blob. So you can imagine it. So it just exercises all those basic operations for block blobs, page blobs. So let's just run that just to show you how it works, and then we'll step through it. So in this case, you can see the file that I've uploaded. And then let's go look back in Storage Explorer here. So let's see in this demo container. You can see now there's that file we've uploaded. So basically straightforward. So now this project is built with our client libraries that make interacting with storage much simpler. And so you can see sort of the patterns here. So you can see we create a cloud storage account, and we use a connection string that's stored in our config file. And then from that cloud storage account, we can talk to different services. We can talk to Blob or Table or Queue. And so we create a client for the Blob service. And now we're going to do a few things. The first thing we want to do here was to create a container. So I created a reference to a container named demo container. And then I called create if not exists. So it goes and creates that container. And then I upload the blob. So in this case, I decide what the address is I want of the blob. And there's this helper function, upload from file. So now you can point this at any size file. And if it's larger than we can upload in one piece, the client library is going to do the work of reading each block and breaking it into blocks and uploading them, and even uploading in parallel in some cases and doing some other things. So it really makes that process more easy for developers. It also includes things like retry logic and other things that make coding against the service easier. So we can list blobs, and then we can delete blobs. So that's the basic developer experience. There's a lot of functionality there. It's all documented on MSDN, both the REST services natively, if you want to use those directly, as well as client libraries for almost all the languages that people use today. All right. So let's go a little deeper into how blobs work. So the blob names themselves. We talked about these concepts before, but the account name is between 3 and 24 characters, has to be lowercase because it's part of the DNS name. So we force it to lowercase only. The container name, similarly, we require it to be lowercase only, can be 3 to 63 characters. The blob name itself can be up to 1,024 characters, and this part we are case sensitive on, so you can, we both preserve case and we're sensitive, so you could have 2 files with the same name with different case. And as we mentioned before, you can use delimiters within the blob name itself to sort of create a virtual directory hierarchy if you want to. So what's in a blob? A blob has a few standard properties, including what type of blob it is, e-tags and last modified data, so you can tell when the blob was last changed. And then the content length, and then the content MD5, so you can make sure as you download a blob, you can validate that the data you have is the same as the data that was stored. You can also add user-defined metadata to a blob. So if you have additional metadata you'd like to store about this file, about this blob. You can have up to 8K worth of name value pairs that you attach with it, and these just have to be valid HTTP header names and values. And you set all those values at once when you update the blob. You can also put metadata on containers as well. And blobs can be up to 200 gig for an individual blob, and that's a number we're continuing to make larger and grow over time. So how do you upload blobs? So this depends on the blob type. The first is if it's an individual blob that's less than 64 meg, we allow to just push the whole thing up in one piece if you like. So we have an individual call, put blob, that lets you put the whole blob in one request and send it up. So it keeps it very simple. If you have larger files, you have a movie or something very large, you split the blob up into blocks, right? And then you upload those blocks individually, and they don't have to be all the same size, but they each have to be less than 4 megs. So you can upload those blocks, and you can do it in parallel, in any order, actually, and just upload them. And once they're all uploaded successfully, then you just make one more call that stitches them together. So one nice thing about this is that when you stitch them together, if you have a pattern in your data where, let's say you have the same set of data repeated in multiple places in a file, for instance, if you build your blocks around that kind of data, you can upload that set of data one time and then point to it in multiple places in the sequence. And so it allows you to do a deduplication of data within a blob. It's pretty powerful. So then you just call put block list, and this essentially stitches together all those blocks and turns them into a file people can use to interact with and download. One nice benefit also of this blob pattern is that it allows you to modify a very large file without having to replace the whole thing to download and upload, a 100 gigabyte file or something. So what you can do is upload a new block that's just the block in the sequence that was modified, and then you just update the block list to point to a new block for that particular part in the file. So it's a unique capability we have in that case. All right. So downloading. Get blob, it does as you expect. It downloads the blob. It includes both the metadata and the data, and we provide those checksums so you can validate the file after you download it. We also allow you to download just a particular range within a blob. And this can be useful for a couple of purposes. One is if you just need to get a particular part of the file, you can. But also it allows you to do parallel downloading, just like we did parallel uploading before. So if you have a very large file that you'd like to download, you can have individual threads, each address a different part of the file, and download them, and then you can stitch them together once they're down. We also have the idea of copy blob. So this is a server operation where you can ask to make a copy of a blob that's on the server to another blob that's on the server. And so it's a full copy. Anything that was sort of an uploaded block that wasn't used by a block list, it gets thrown away. Snapshots are also thrown away. But we do a couple of unique things. One is that, of course, this copy is asynchronous, because if you need to move a very large file between locations, that can take a while. So we like to start the copy and then check on its progress over time. If you're copying a blob to a new copy in the same storage account, then it's a very fast operation. It's actually just a metadata operation. We just point two file names at the same set of data. So that's very quick. We also allow you to copy from external sources of data. So if you can provide us a URL, we will, from the service, reach out and pull the data from that URL. So that's great if you want to import data from some other web property or from S3 or something else. It's a great solution for that. All right, so how do I see the blobs I have? How do I list them? As you'd expect, we have this list blob operation on a particular container. We allow you to page through large result sets. If you have lots of blobs in a container, you can have as many as you like. We also allow you to filter. So give me just the set of blobs that start with a particular prefix. And then we talked about before that sort of virtual file system. We also have this function where you can say, tell me the unique set of prefixes based on using this character as a delimiter. So if you say, give me the prefixes you see behind a backslash, and we'll give you back that list of folders, essentially, that nested list of folders that you can then use to query just particular sets of files in there. So it enables that virtual directory scenario. And then delete blob, as you'd expect, you can just delete a particular blob. We also provide this idea of deleting a whole container. as a more efficient way to delete a set of blobs. If you've done SQL Server, this is essentially similar to truncating a table instead of deleting all the individual rows in a table, so a much quicker operation. All right, so I showed you the code earlier. We provide client libraries that really make working with this code, this service simpler. That includes things like breaking things into blocks, doing parallel uploads, the retry policies. We also provide capability to help with client-side encryption. So if you need to manage and encrypting the data on the client, we've got infrastructure that makes that simpler. Okay, so blobs also support versioning. So this is a powerful capability. We do it through something we call snapshots. So you essentially create a snapshot based on the current state of a blob at some point in time, and you get a read-only copy that's the snapshot that you can download and read. It essentially becomes the name of the blob with a date and timestamp appended to it. So kind of what you'd expect. These things can be read, and you can also copy from them to do things like copy blobs or even restore over the current state. So like you might do with a virtual machine, you can go back to a snapshot and make that the current copy of the data. And you do those with copy blobs. So you can imagine I can point to a snapshot as the source of a copy blob operation. I can also make the destination be the existing blob, so I can replace the current value with the value that was the snapshot. When you make a copy of a blob, I think I mentioned this before, the snapshots that you had defined inside it don't go with the blob. So they stay with the original one. And when you try to delete a blob, you can't delete one if there's still active snapshots in it. So we assume if you took a snapshot, you wanted to preserve it, so we make you remove those before you delete a blob. Okay, let's talk a little bit about concurrency. So there's lots of scenarios people build for applications where there's multiple different servers or users trying to operate on the same set of data, and there's a couple of ways to manage that. We talk about it in terms of optimistic and pessimistic concurrency. The difference there is essentially based on how often you think this is going to be a problem. So if you think in your scenario, most of the time everybody's working on their own pieces of the system, and when they make a change, it's not going to be a conflict. It's more scalable to use something called optimistic concurrency. And this essentially says, try to do the update, but make sure when you do the update that the file you're replacing is the version it was when you read it, so that you know nobody changed it since you read it. And so we support that pattern called optimistic concurrency, both with timestamps and e-tags. So the idea is you can use these HTTP primitives of if modified sense or if match on these headers, these either timestamp or e-tag based header values. And you can essentially say, download a file, and when you download the blob, you store the e-tag, and you make some changes to it, and then you go to upload it. You can put a conditional on the put of the changed file that says, only update this file if the e-tag matches this version. And that means it's still the version it was when you downloaded it, nobody's changed it. If it doesn't match, the operation would fail. You can also use it to do other unique things, though. You can say, only download this blob if it's not the version I already have, so I don't have to waste time pulling things over the wire. So there's a bunch of different interesting things you can do with those if-match headers. Let's see. Pessimistic concurrency is that case when it's almost always going to run into conflicts, and I don't want to have to keep retrying and recovering from them. I'd like to just make sure they never happen. And so the way pessimistic concurrency works is essentially you need to lock the resource so that nobody else is operating on it. And in Azure Blob Storage, we do that with something called a lease. So the lease, you make a call to acquire a lease. If somebody else has a lease, you won't be able to acquire one. So this gives you exclusive write and delete access to that file. You can get temporary leases, so 15 to 60 second kind of leases, and you can have your process continue to renew those if it needs to keep operating exclusively on the file. Or you can take the approach where you grab a lease that's infinite and it stays forever. The first scenario works better if you could have a process blow up and you wanted another server to be able to pick up and try again. So those leases automatically expire. So you can use either pattern, whichever works for you. You can also do something where you chain the leases together. So if I take a unique lease on the operation and I need to hand it to some sub-process to operate it on, I can acquire another lease based on that lease, change the lease ID, and have some sub-process operate on it until they're done and then give it back to me. So it's sort of a controlled workflow and chain of those locks. You can also acquire leases on containers to keep someone from deleting a container until you're ready. And then the third concurrency model is essentially no concurrency model, and this is really the default behavior. So if you don't explicitly use optimistic concurrency, if match header values, or pessimistic concurrency with passing least values in and out, then whoever updates the thing last is gonna win. So you can potentially lose data that way, but in some scenarios that's fine. All right, so more details there if you want to dig into concurrency. All right, so that's great if you're a developer. What if I just want to, how do I get some value out of this service if I don't want to write a bunch of code myself? And so there's a couple of sort of common scenarios and solutions that people face that partners have built great solutions for that you can take advantage of today in your existing infrastructure. So one of those is this idea that I'd like to have global access to a sort of a central set of data. Sort of the branch office file share kind of scenario is the most common, right? And so in this scenario, you want file or block access. You want a central repository that is this one source of truth on that data. You want it to be available anywhere, and especially available on the edge in your local offices, and use edge caching and other approaches to make it available efficiently locally. But I'd like to be able to take locks that keep other branches from modifying a file if I need to operate on it exclusively. So this would leverage the kind of the locking mechanisms we just talked about. And I'd like to also take advantage of local security things in the on-premise scenario. So this is a very common pattern people face. And there's been a great set of partners who built solutions that address this specifically. So one of the specific ones, Panzera here, was used by an engineering company, a global engineering company. If you're familiar with the Big Dig in Boston, you ever heard that term? They essentially dug a giant tunnel under the city of Boston. It was a famously over-budget engineering project, but these were the guys who were part of that engineering project, and they have this problem of they have engineers spread all over the world, and they're trying to collaborate on projects, but they're trying to operate on very large files that are in one location or another, and so they were constantly chasing, we need more and more WAN bandwidth between these locations, and maybe that'll let us have decent performance. And they were just in this downward spiral of paying more money for bandwidth and still having poor performance. I mean, it just never really did it. And so they used a Panzera solution in this case, which essentially puts file shares in each local branch, pointing back to a central store in Azure. And so they were able to have individual locking of those files, but operate at local LAN speeds against them. And it was really a great solution. And it allowed them to really change their whole architecture, get rid of these very expensive dedicated WAN links and just use normal high bandwidth internet connections, and get rid of WAN accelerators and a lot of things to make their scenario much more simple. And so I encourage you, if you've got this pattern, to take a look at these partner solutions, and there's others as well. But these are ones we've worked very closely with. Okay, about 12 more minutes. How are we doing? Everybody keeping up? It's a lot of talking from me. So we'll talk through a couple of patterns and some ways you can address them with Azure Storage. The first is just this idea, I need to move a bunch of data. I've decided I want to do it. Now I want to push a bunch of data up there. How do I do it? And so we provide a tool called AZ Copy. You can think of this as like RoboCopy, but for Azure. So you can use this tool to upload very large or lots of individual files up to Azure Storage, and it takes care of doing things like efficient parallelization into multiple threads, journaling and reliable copies and things like that, working over unreliable networks. So it's a great tool to help achieve getting your data into Azure just to begin with. And it's built on top of a library, actually. So if you'd like to build a custom tool that does things like that, sort of bulk data movement into Azure, we actually provide the guts of the AZ Copy tool in a library that you can build into your own tools. So that's this data movement library. So check that out. We also have this pattern of delegated authorization. So storage today is secured with essentially shared keys. And they're sort of an administrative key. So if you have the key, you can do anything, which is fine if you only have a couple of people who need to operate on the data. But often there's patterns where you have all these distributed applications, and handing this super powerful key around doesn't make any sense. So we have this idea of delegating authorization through something called a SAS token. And this allows you to define a specific set of access on a specific object and generate a URL to that object that includes what we call the signature. And that signature is generated and signed by the key. So you need to build a process. You can see this box that says token issuer. you would build your own process that decides who should get what kind of access, and then you would issue these SAS keys. So this is a great scenario if you want to hand out access to a mobile device or to some untrusted partner or otherwise, where they can have specific access for a specific limited period of time, maybe even from a specific IP address. I mean, it really allows you to constrain the access that a particular caller has. So that's SAS tokens and delegated auth. Encryption is also an important scenario for a lot of people, and we provide sort of two alternatives here. One is to just let us take care of it. So you can essentially, you saw me when I created a storage account, there was a place to check whether I wanted encryption. I think we're going to get to the point where we don't even ask, we just encrypt everything all the time. But today you can optionally turn on storage service encryption. And if you do that, then we just store it encrypted, and when it's written to the disk, it's stored with a Microsoft managed set of keys, and it's encrypted and safe. If you need to use your own key, and you sort of got very security sensitive data, you want to make sure you can remove access by removing access to that key. We're going to build that bring your own keys, customer provided keys scenario for storage service encryption in the near future. We're working on that right now. Today you can do that through encrypting your data actually in the client. And so we've also got solutions built into our client libraries that integrate with Azure Key Vault that allow you to do your encryption in the client with very little code, and then the data is obviously written, and then we couldn't even read it if we tried in the service. So encryption as rest is important. Once you have all this data in there, one of the most common things people want to do with it is search it, right? And so we have the ability to connect Azure Search to Azure Storage and build search indexes that you can use to search and find data within it. And you can both search the objects themselves, if they're files formats that indexers are aware of, like PDF or Office files. You can also have it index the metadata that you add. So if you just want to provide in the metadata everything you might search for, and not have them have to crack open the file, then they can also index based on that metadata. So there's a link to follow up on connecting Azure Search. So tiered storage. So this is really key for people. It's really about managing cost. But people have different sort of categories of data. Commonly they have data that they're using very regularly. They put it in there and they're reading and they're writing and they're changing it. It's sort of live, active data. But then there's other classes of data where they store it and they may never even look at it again. Or if they do, it's pretty rare or it's a very small percentage. And so it doesn't make sense to pay the same price to store data that you're never going to look at. And so we've built this idea of two different tiers of data. So you can essentially tell us which pattern of data is this, and we'll have a different pricing model based on that. So the way you get to the data is exactly the same. It's the same set of APIs, the same set of options for how you protect the data for durability-wise. What's different is just how we price it, and it allows us to do capacity planning on balancing storage and CPU and all these other things on our service. So with the standard hot tier, you pay a certain amount to move data in and out, and you pay a particular rate to store sort of gigabytes per day, gigabytes per month. With the cool tier, you pay a little bit to push the data in and out, a little bit higher values for transactions, a little bit higher cost to write data and read data, but a much lower cost to store it. So twice as much sort of per transaction and half of them, and much lower sort of gigabyte costs. So you can see, what is this, 2.5 gigabytes per month versus a quarter of a gigabyte, 25 cents for a gigabyte per month, so, or a quarter of a penny. So anyway, it's a much cheaper storage. And this is very useful for data that you don't use very often. So today you set this at the storage account tier. You can move data from one, you can change the tier of a storage account from cool to hot and hot to cool. If you move it to cool, it's no cost. If you move it back to hot, you essentially pay the price of reading it one time, essentially reading each object one time to move it back to hot. In the future, we want to move to where you don't even have to make a whole storage account hot or cool. We want to make this at the object level and make it policy-based. So the idea would be that you can define a policy in your storage account that says, for this data, once it's been there a week, it's probably never going to get read again or written again. And so make that particular object cool after that period of time, or based on file name or any other kind of policy you can imagine. That's sort of the idea, is we have a policy-based, and you can move things back and forth as it makes sense. So, so that tiering is really valuable in terms of being able to have lower cost for things like backup scenarios, right? So I wanted to take you through, in just a couple of minutes, an example of a customer who's leveraging a partner solution and taking advantage of the cloud economics and cool storage. So Seminole County Public Schools is a school district in the state of Florida in the US. And they're sort of a medium-sized sort of enterprise, you might think. A few hundred servers, a bunch of students that they manage. And so they have certain obligations where they have to back up their data. But they felt like they were paying way more for this than they needed to. And there was a bunch of sources of that cost. One of them is just the cost to store the data. But also the amount of effort it took to exercise and make sure they were ready to restore the data was very expensive. So they would store their data, back it up to tape. They would drive those tapes off to an offsite location and store them. And so there was a cost to that. And if they ever wanted to test restore, their dedicated sort of disaster recovery site was in a different state. It was way up the East Coast. And so they would have to send a person all the way up, hundreds of miles away to go there and try the tapes and try to unload them and see if it worked, right? And so that was just a labor-intensive, expensive process just to make sure your backups are working correctly. And so what they decided to leverage was a particular solution from NetApp called AltaVault. And the way this works is essentially you replace the on-premise tape target for backups with another target, which is actually this AltaVault device. So all the software and all the systems they're using to actually take backups don't change at all. They just, instead of sending to this tape machine, they send to this AltaVault. And what this AltaVault is a local, essentially, cache of backups and a connection to a cloud-based backup. And so this AltaVault is connected to their Azure storage, and as they push backups into it, those backups get synced up to the cloud, and then the ones that they're used most recently get cached locally, so they're available for very quick access. And then if they ever need to retrieve another one that's not in that cache, they can just go and pull it from Azure directly. And this is available both as a hardware appliance as well as a virtual appliance. And it really helped, especially for those disaster recovery testing scenarios. So now they could, even in the cloud, they could spin up a virtual machine and a virtual AltaVault device and use the backups from Azure and test them all in Azure without ever having to travel somewhere to prove these things. And it made them very nimble about where they could restore, and it was a very powerful solution for them. So this took advantage of that cool storage, so storing was very inexpensive. But then they get all the durability things we're doing about multiple regions and things like that. So it was very helpful for them. It helped them retire their whole tape drive solution. It was very inexpensive in terms of what they bought to replace it. And they were able to get super benefits out of the things that device does, like deduplication, 18-to-1 reductions in the size, for instance, of those backups, so that they're able to store a lot more of those backups locally and be able to operate on them very quickly. All right, so this is a very common pattern. People want to do backups from on-premise. They want to target storing that in a central place in the cloud and be able to store it very cheaply for as long as they need to. And they'd like this to fit into their existing infrastructure, so it just looks like any other device. And they want to be able to do disaster recovery in the cloud and on-premise in a different location. So this is a very common pattern we see. And again, there's a whole set of partner solutions which address this. Those include from the top sort of backup software providers, Commvault and Veritas, which their software will integrate directly with Azure storage, as well as devices like the NetApp device that we talked about that provide additional benefits in an on-premise presence. So lots of very cool stuff there for the backup and disaster recovery solution. So in summary, we talked through Azure Blobs. We talked about scalability, the durability options, how you secure it. We talked about the different capabilities of it. We talked a little bit about the partner ecosystem and how you can use it to really save a lot of money in your solutions. So if you want to learn more about Azure Storage, I encourage you to follow this link. I also would love to hear your feedback in your evaluations. I know you guys have been seeing this all week long. You're almost there. The party is moments away, but I'm open to taking your questions if anyone has any questions, or we can talk later over a beer, whichever you prefer. So thank you. Any questions? All right. Enjoy the party. Yeah, go ahead.
It's probably not appropriate to mention Google here, but
Oh, sure.
Google has got a service, back-end service, especially for app developers who don't have the skills and the time to fiddle with the infrastructure and database in the back-end, called the Firebase.
Uh-huh.
Are you aware of that?
I'm not specifically with what you're talking about with Firebase, but
No, I just want to check if Microsoft has such an offering.
we have a lot of offerings for developers way beyond storage, right? And there's a bunch of different scenarios. So I would look at the app services from Azure, and there's also a bunch of work in the mobile services team. You probably saw earlier sessions from the Xamarin guys about some of those services. And we're doing more and more work there to make that very simple to get on board to the cloud. All right, thanks, guys.